Good evening, everyone. My name is Sir Jude, and here's the video lecture for our lesson this morning, which is about plane mirrors. So, we started our session earlier by detecting the errors in the following photos. So, in the first photo, we see that the object and the image are not the same, and they must be technically the same because, as we mentioned before in law of reflection, what you project to the mirror must reflect it back to you as well. The same thing is also true with the second picture wherein you have the object, which is a pawn, and the reflected image is a queen. And this is practically impossible because these are two different chess pieces. And lastly, for the girl posing with her new hat in front of the mirror, there are some errors when it comes to the orientations and the positions of her arms. So in this session or in this lesson, we will finally learn how to create images and identify the properties of images formed by plane mirrors. So this was our first and only problem for this lesson. So let me read it to you. A 5 centimeter tall marquee letter is 10 centimeter in front of a plane mirror. Create the image and interpret its loss, which is an acronym. So our object is a 5 centimeter tall marquee letter, which is in this case, letter B. Now, the ray diagramming that I demonstrated to you a while ago, uh, when you search or browse in the internet for other sources or to double check now, you will see that there are lots of possible ray diagrams for images formed by plane mirrors. And I deliberately chose 5 lines, no, so that it could be easier for everybody. So the first line that we draw is there is a light striking to the mirror as usual, horizontally, and then it is reflected back. That's why you see two arrowheads. And then next, there is another light striking from the top of the object, then reaching down to the bottom of the mirror. And that incident ray reflects uh, at the bottom of the mirror at the southwest portion. So as you can see, we have three unbroken lines, and these three never intersected with each other. That's why we still have to extend the reflected rays to the other side of the mirror. So our first reflected ray is the first arrow that was drawn a while ago. So extend it horizontally to the right to the other side of the mirror. And finally, the other reflected ray is the third arrow, wherein when you extend it in the northeastern portion using another broken line until it reaches with the first broken line. And once you connected the two, you now have the point of intersection, and that signifies that there is an image formed in this orientation. So our first goal to create the image is now officially accomplished. Now is the time to interpret its LOST. So what does LOST stand for? We discuss them one by one. We start with L, which stands for location. For location, you have two options. Front, wherein the image is at the left side of the mirror. And the other one is back, wherein the image is at the right side of the mirror. Now, let's identify where the image actually is. So when something is already given to you in print, that's the object. And when you have to perform ray diagramming and sketch uh, the image using the point of intersection of the lines, that's the image. So all we have to do is just to find the location of where the image was formed. There are two sides of the mirror, specifically in this ray diagramming. The left side, which we will label as front, and the other one is the right side, which we will label as back. Ayan. So obviously, the image is found at the right side of the mirror. That's why the correct answer is, for the location, the image is at the back of the mirror, specifically 10 centimeters. So you might be wondering, where did 10 centimeters come from? So going back to the problem, we have a 5 centimeter tall marquee letter that is 10 centimeters in front of the plane mirror. The object is positioned 10 centimeters in front of the plane mirror. So we expect that because we're using plane mirrors, that the image will be located 10 centimeters at the back of the mirror. All right, so that's it for the location. Okay, next. The next is the trickiest of the four to interpret, which is the orientation. And we have three choices for that. So first, we have upright, wherein the image has the same orientation as the object. So exactly a twin. No? Next is upright and laterally inverted, wherein the image has the same orientation as the object, but with reversed left and right sides. And finally, number three, we have inverted, wherein the image lies upside down. So in this case, with letter B, no, it may look inverted or written upside down, but it is actually upright and laterally inverted. Remember, because the point of intersection is at the top of the optical axis. Therefore, this is considered upright and laterally inverted. And you can also see wherein its left and right sides compared to the object are already reversed. So, because a lot of people are confused about orientation, I devoted some slides solely for orientation. So, in this case, which uppercase letters of the alphabet will you expect to have the same orientation when placed in front of a plane mirror? And we have 11 answers or 11 letters to testify that. Specifically, if the font is like this, no? So we have letter A, letter H, then I, then letter M, letter O, and then letters T to Y. So what's special about these letters is that given this orientation and assuming that our plane mirror is standing vertically, no, then the image that will be presented looks exactly the same as the object. And that's because they are vertically symmetrical. So what does vertical symmetry mean? For example, with letter O, sorry, for example, with letter O, if you cut letter O vertically, so its left and right sides are vertically symmetrical to each other. Unlike other letters that weren't encircled or oblong, no, their left sides and right side are not vertically symmetrical with one another. So for these letters, A, H, I, M, O, and then letters T to Y, we expect that their images in front of the plane mirror will just be upright because their left and right sides are not reversed. Okay, moving forward. Now, let's focus now on upright and laterally inverted images. So select the image that will be formed if the following objects are placed in front of a plane mirror. So we have this alphabet wall with Christmas lights. And because we're targeting upright and laterally inverted images, the correct answer is the bottom left um, image. Okay, next. So for this logo, I love science, no? The correct orientation of the image should be the fourth one. Okay, next, third example with this jacket. So the correct orientation will be the third one. Now, for the fourth example, the red crayon, focus on the label of the crayon. The correct orientation will be the second image. And finally, for the clock, signifying 5:30, whether it's AM or PM, when you face that in the mirror, the resulting image will be the first one. So I hope that the distinction between upright and laterally inverted images is clear to you because you already have an abundance of examples from the previous slides. Now, one practical application of upright and lateral images is the printing of the word ambulance in ambulance vehicles. So you might be wondering, why is it printed like that? So that's not actually an error, or that's not actually a mistake. That's actually intentional, because if other drivers cannot be signaled by sirens, then by looking at the side mirror, they can see the correct and clear as well as the readable version of the word ambulance. So that which is a calling card for urgency and sense of emergency, because someone has their lives in danger and we need to rescue them immediately. Okay, so enough on the orientation. Let's now complete the other half of lost with letter S, which means the size. For the size, you have three options. So first, reduce, wherein the image is smaller than the object. Second is same size, wherein the image has the same height as the object. And then third, we have magnified, wherein the image is bigger than the object. So, easy peasy, magkasing tangkad yung object tsaka image natin. That's why for the size, the image has the same size as the object, specifically 5 centimeters. So where did 5 centimeters come from? So going back to the problem, just mentioned that the marquee letter, our object, is 5 centimeters tall. And because they have the same size, then therefore we expect that the object stands 5 centimeters tall as well. You don't expect that when you face yourself in the mirror, you get uh enlarged or you will shrink, no? Because the mirror does not, the mirror only reflects us uh what you project to it, specifically for plane mirrors. Okay, so size is the easiest of all the loss interpretations because you're just comparing the height. And finally, for the T is the type. So for the type, we have two options. So first is real, wherein the image is formed by the intersection of actual rays or unbroken lines. And finally, we have the virtual, wherein the image is formed by the intersection of imaginary or broken lines. Or broken rays, pala rather. It's actually difficult to explain this one because especially that I think it's better to delve more on real and virtual as well as the actual and imaginaries once we finally tackle the curved mirrors, converging and diverging, because the actual and imaginary rays given actual light rays now will play a significant role. But in the moment, let's just rely on how the line on what type of line did we use, no? So we're only focused on the image, and the image is found at the right side. And the image is formed by the intersection of imaginary rays. That's why for the type, the image is considered virtual. All right, so that's it. We already finished creating the image and interpreting the lost. So you don't need to worry about memorizing the lines, no? Their which line to draw first, how does the line look like, because it will be presented to you in your performance task and upcoming long test, no? And Obviously, in the exam, I will not, in the quarterly examination, all ray diagrams will be printed. So you don't need to worry about memorizing the memorizing the lines for the ray diagramming or sketching of the images. Now, because we're finished with the discussion, it's time for the review recap. And this is entirely different from our review and recap in the previous lessons because here, we're going to examine the errors in each object image pair and recommend what needs to be done. So, in the first example, we have our object is letter C, and this is the wrong image. So, all wrong images in this slide are represented by a red font or red letter. So the problem with this example is that the image is in front of the mirror, which is uh pagkatabi mo na yung sarili mong reflection, something is very, very wrong with that mirror. So what needs to be done? So the image must be at the back of the mirror, no? So that way. Ayan, na-course correct na natin yung um, pagkakamali sa drawing. For the second example, so anong mali diyan? So the object is given that distance while the image is nearer to the mirror, no? So hindi pantay yung distance ng object sa mirror versus ng distance ng image sa mirror. So, ano kailangan gawin? The image must be farther from the mirror. We have to move the image a little bit further back, just like that one. Okay. Third example, no? So we have letter E as our object. And what's wrong with that is because letter E is not a vertically symmetrical letter. So given that wrong image, that's upright. And because E is not vertically symmetrical, we expect it to be upright and laterally inverted, which is that kind of letter E. Number 4. So our object is letter F, and this one is easy to detect because we expect that our images have the same height as the object. So the image is reduced, and we have to enlarge it to the point that it must be the same size as the object and not bigger as the object. Okay? So that version of letter F. And finally, for the last example, we have two errors for this one with the object letter G. So first, the image is upright. No, we don't expect letter G to have an upright image because it's vertically asymmetrical. And the other one is the image is too large or is magnified compared to the object. So how do we course correct this image? So the image must be upright and laterally inverted as well as the same size as the object, or in this case, that orientation and size of letter G. Okay, so let's summarize the LOST, location, orientation, size, and type for that characterizes the images formed by plane mirrors. No? So first question, location, where is the image formed? It will be always formed at the back of the mirror. Second, orientation, how does the image look like? So the options here are upright, upright and laterally inverted, as well as inverted. And the correct answer is upright and laterally inverted. Same orientation as the object, but reverse left and right sides. The left side will become the right side in the mirror, and the right side and of the object will become the left side in the mirror. And finally, the size, sorry, not yet finally, but for the third one, the size, what is the size of the image? So we expect it to be the same size or the same height as the object. And last but definitely not the least is the image real or virtual. So judging by this photo alone, we cannot determine whether the image is real or virtual because we need the sketching or the ray diagramming. And based on the ray diagram, All images formed by plane mirrors are considered virtual because they were formed by the intersection of uh, imaginary light rays, or in this case, broken lines. And there you have it. That concludes our video lecture for today. So remember that we have our performance task 2.3 tomorrow because on Thursday we will have a shortened period. So bring all your materials for tomorrow and see ya. Good night.